Hello everyone. So this is the 10th week of the course Water and Wastewater Treatment. So I am Mansi Tripathi. I am TA for this course. I am here to help you solve the weekly assignments as well as to help you solve if any doubts you have in your subject. So we'll start. I'll share my screen. You can answer the questions and I'll show you answers also so that you can match it with yours. I'll share my screen now. I hope it's visible. So as I've told you, water and wastewater treatment, this is week 10 problem solving session. So we'll start with question number 1. So question number 1 is, hardness of water is usually due to the presence of potassium, calcium, chlorine and potassium, magnesium and calcium and chlorine. So as we know, there are different types of water. So there will be a category of water which we call hard water. Why we call them hard? So first of all, it won't form scum, like it won't form lather when we are dissolving soap in it for washing clothes and anything. Also, this hard water may precipitate, so it may form some layer in the boiler feed. So that is why hard water is not desirable. So to remove the hardness of water, first of all we should know what is hardness, okay, and why they are present over there. So this question will help you understand that what are the particular ions that helps to like put the hardness in the water. So either potassium, calcium, chlorine, potassium, magnesium, calcium and chlorine. So the first hint will be, these are ions, cations, okay, not anions. So when we say cations, it means plus, positive charge, okay. So when we say that, then it means this chlorine will go, okay, because chlorine is anion. So B and C are gone. Now option A and C are left. So what can be the answer? We'll see now. So the answer is C, magnesium and calcium. So this hardness is basically due to a multivalent cation. Okay, so multivalent means when we write magnesium, we write 2 positive, and calcium also 2 positive. But if I say sodium, which is also a positive ion, will that cause hardness? So the answer is no, it won't cause hardness. These will cause. So means multivalent ions, multivalent cations. So the charge should be N plus. N should be greater than 1. Okay. So if I say aluminium, charge on aluminum is 3 plus. So yes, it will cause some hardness, okay. But basically in water, magnesium and calcium are there, okay. So that's why the answer is C. Coming towards next question, select the incorrect statement from the following option. Permanent hardness is due to dissolved chlorides in sulfate of calcium, magnesium. Permanent hardness can be removed by boiling of water. And permanent hardness is also known as non-alkaline hardness. Just a second, I need to admit a student, that's why I have to go back. So at 6 only I started the session. So I'll repeat question number 1 again, what I have told. So this question was that the hardness of water is usually due to the presence of, these were many options, and we found that magnesium and calcium is correct. So why? Because hardness is present due to the multivalent cations. So if we say magnesium is 2 plus, okay, so there will be some, this is multivalent 2, calcium is 2 plus, so that's why it's causing hardness. When we say sodium, so it's not multivalent, okay, this is monovalent, that's why there won't be any hardness. But if we say aluminium, it is 3 times 3 plus, so it will also cause some hardness. But most commonly in the water, magnesium and calcium are only present, that's why these are the most common cations that will cause hardness in the water. Coming to next question, select the incorrect statement. We need to find out the incorrect statement. So there are 2 types of hardness, one is temporary and the other is permanent. So we need 2 types of hardness, one is temporary and the other is permanent. So calcium and magnesium is common, calcium and magnesium is common. So what change is the anions, okay, so the anions are only changing. So just a second, I need to admit a student. So in this question, what we saw that there are 2 types of hardness, one is temporary, other is permanent. So when we say hardness, so 2 things are fixed, calcium and magnesium. So in both the hardness, temporary or permanent, what change? It anions. So there will be different type of anions. Whatever anions we keep, the type of hardness will change. It can switch from temporary to permanent or permanent to temporary. So the first option is permanent hardness is due to dissolved chlorides and sulfates of calcium magnesium, okay, chlorides and sulfate. Permanent hardness can be removed by boiling water. Third is permanent hardness is also known as non-alkaline hardness. D option is the difference between the total hardness and the alkaline hardness is called non-alkaline hardness. Okay, so what is alkaline hardness? Alkaline hardness is a temporary hardness. Okay, so what can be the correct option? So the correct option is option B. What are the anions in the temporary hardness? One is carbonate, bicarbonate, so that is why they are called alkaline hardness, because these can cause alkalinity as well. Okay, these can cause alkalinity. So OH, when we will put OH, it's highly alkaline, carbonate and bicarbonate are in the middle. But when we say permanent hardness, so there will be chlorides and sulfates. Okay. Moving towards next question. Alkalinity of the water can be defined correctly as it is the measure of the, talking about alkalinity, which are due to OH means hydroxides, carbonates and bicarbonate. So alkalinity is the water, we have to define the alkalinity, is the measure of ability of water to neutralize carbonates. When it's already containing carbonates, why it will neutralize carbonates? Okay, it is a measure of ability of water to neutralize H plus. It is a measure of the ability of water to neutralize hydroxide or none of the above. Okay, so the correct option will be option B. Yes, correct option is option B, because alkalinity, these are the basic compounds, so they can easily neutralize acid. One example is HCl. This is acid, right? Plus NaOH. What it yields? It yields NaCl. This is the common salt, and H2O. So what is happening here? This alkalinity, which is present in the form of sodium hydroxide, it is neutralizing this acid. Okay, and what actually it is neutralizing? H plus ions present in acid is neutralized by OH ions present in alkalinity or the base. So this is what it is happening. It can neutralize other things also. Okay, weak acids. This is the example of strong acid, strong base. It can neutralize weaker acid and weaker base also. So moving towards next question. Boiler feed water should also be hard in nature. This is the first example I told you why we need to avoid hardness. So I gave you example of washing clothes and the boiler feed water. So what can be the answer? True or false? What does hard water do? Hard water forms the precipitate. Imagine if you have a flask or any utensil, steel utensil, you are filling it with water. So whenever you are boiling it, you are seeing some precipitates in the sides. So this happens. So in some equipments we do not want these precipitates. Boiler feed is one of them. So here precipitates are not desirable because this will hamper the flow or the functioning. So that is why the answer is false. Okay. Next question is, iron concentration obtained for a groundwater sample having pH is equal to 8.1. We need to find out the iron concentration. Groundwater sample is having pH 8.1. Means how much H plus ion is there? pH is negative log of H plus ion. So H plus ion is 10 raised to power minus 8.1. Okay, is given below. The total hardness we want to calculate in milligrams per liter and the non-carbonate hardness. Okay, carbonate hardness means alkalinity, and these we want in terms of milligram per liter. So I told you when we have two types of hardness, temporary and permanent. What is common? Common is calcium and magnesium. So when we want to calculate the total hardness, what we can calculate? We can just calculate the calcium and magnesium irrespective of the anions. So we have to just calculate the calcium and magnesium, that too in terms of calcium carbonate. So we'll see the solution for question number 5 in the next slide. This is handwritten solution. So how much magnesium? We have 6 and calcium we have 100. Okay, please note down the values. It will be better if you do this solution, then we can see the answer. Try to solve it. We'll see answer in few minutes. This will improve your understanding. How to calculate the equivalent weight? Okay, we'll see the solution now. So total hardness is magnesium plus calcium. So we are converting them to carbon calcium carbonate, because only then they can be added. We cannot add like 100 plus 60 then we convert them into calcium carbonate. That will be a wrong approach, because both the equivalents will be different. So just to add them, first of all we have to convert them into equivalent weights, then solve. So equivalent weight of magnesium is magnesium into equivalent weight of calcium carbonate, equivalent weight of magnesium 2 plus. So this is in a equivalent weight of calcium carbonate is biomass, total atomic mass is, just a second, total biomass is 100 divided by 2. So this is how we will get equivalent mass of calcium carbonate, which came out to be as 50. So this value is 50. What is equivalent mass of Mg2 plus? The molar mass is 24 divided by the valency. We will get equivalent weight of magnesium, which is coming out as 12. That is why we are getting this division 50 divided by 12. And when we will multiply it with the amount of magnesium present, we will get the magnesium equivalent. Same we are doing for calcium equivalent. Then only we can add. We cannot add 66 plus 100, then we are doing anything, then we are converting into equivalent weight. So that will be wrong approach. So only equivalent weights can be added. What was the next question? The non-carbonate hardness. So here I told you what are temporary hardness. Temporary hardness were due to carbonates, bicarbonate, okay, and OH ions. So here bicarbonate is given but OH is not given. So you can calculate OH from here. Either what you can do is you can calculate permanent temporary hardness from here and subtract it from total hardness, or you can calculate the permanent hardness directly as given in this question. If these things are not given, what you should do, you have all the values of the permanent temporary hardness, you can calculate the non-carbonate or the permanent hardness from that. We'll see the solution now. The total alkalinities consist of carbonate, bicarbonate and OH. Total alkalinity HCO3, because these things are not there. Okay, we should take OH also, but OH will be very less. See, I'll tell you how. OH will be 10 raised to power minus 14 divided by 10 raised to power minus 8.1. It will give 10 raised to power minus 6.9. OH. Sorry.
Have you ever wondered why?
Okay, and when we will convert this value in terms of equivalent, it will be very less. 5.9 into 100, 50 divided by 17 Also, this is in terms of moles per liter. So we want to convert it into milligrams per liter because everything is given in milligrams per liter. So to convert it into milligrams per liter, we will multiply it by the molar mass, 17. So this thing and this thing are cancelled. We will get 50 into, or we say 5 into 10 raised to power 4.9 minus 4.9. So when we will add or subtract this from the values, it will be very less. So that's why we are ignoring it. So total alkalinity will be due to just bicarbonates, multiplying it by equivalent weight of CaCO3 divided by HCO3, equivalent weight of HCO3. So this is what we get. See, just imagine if we are adding this to 5 into 10 raised to power minus 4.10, it won't affect, right? So that is why we are ignoring it. So what is carbonate hardness? Total hardness is equal to like carbonate hardness is total hardness. This is written wrongly. So carbonate hardness is equal to alkalinity. Okay. So what is non-carbonate hardness? Is total hardness minus carbonate hardness or alkalinity. So we have calculated already total hardness here 275. So just we have to subtract the carbonate hardness 275. So we are getting 70 milligrams per liter. We can also do this question by measuring sulfate and chloride, and by solving it for calcium, how much calcium sulfate, calcium chloride, these things will be found. We could also do like that. Okay. But here we have to do two calculations for sulfate and chloride, but in this case you have to do only one calculation. That's why this is shorter path. So the next question is, which of the following statement regarding lime soda process is correct? Lime soda is softening process. Lime removes carbonate hardness while soda removes non-carbonate hardness. Only carbonate hardness is removed in lime soda process. Lime removes non-carbonate means C is opposite of A equation, and only non-carbonate hardness is removed. So please try to answer this question. We'll see the solution in a while. We'll see the solution. So the answer is correct. Lime removes non-carbonate hardness while the soda removes carbonate hardness. Okay, moving towards next question. Recarbonate the water after lime soda process. What will happen? What happens after this whole process? There will be excess of we want to the water will be kind of aggressive. It may dissolve from the pipeline, it may dissolve minerals from the pipeline in which it is flowing. That is why recarbonation of the water is necessary, so that it can be stabilized. Okay, so why do we do this? To removal of excess soda from water, for the recovery of lime, lowering the pH and increasing the alkalinity, the removal of non-carbonate hardness. We'll see the answer now. So the answer is for lowering the pH and increasing the alkalinity. So why we want to increase the alkalinity? To increase the amount of minerals present in water so that it won't dissolve from the surrounding pipeline. Moving towards next question. HCl or H2SO4 is not used to decrease the pH after addition of lime because we are doing recarbonation by using CO2. So why are we not putting HCl or H2SO4? They are stronger acids, right? So why are we not putting them? Please try to answer this question. We'll see the solution now. So the option is C. Cl or H2SO4 results in unnecessary increase of the concentration of dissolved solids. Okay, so in HCl and in H2SO4, these things are present, chloride and sulfate ion. So they will just increase the amount of total dissolved solids. Okay, because some calcium, magnesium, all these things will be there, so they can react with these acids and form the total dissolved solids. Okay, and also if we are putting these things, there can be drastic change in the pH. This is one more reason. That is why we try to use the milder acids to decrease the pH. Moving towards last question. Okay, this was the last question it seems. Okay, so any doubt in any of the questions? Okay, then we'll close the session now. In case of any doubts, you can ask me in the next session or you can write in the forum. Okay, so we'll close the session now. Thank you everyone.